we're going to take a minute and look at special products in polynomial multiplication. So basically the idea is enough of these things show up often enough that you kind of start to accidentally memorize them. Okay, so one of them, for example, might be something like this. A plus B, A minus B. And one of the nice things about memorizing the special products is that later on, whenever you're, what do you call that thing? Taking things apart, factoring things. Whenever you're factoring things, if you recognize a special product, it makes it easier to factor. So one of them that you'll learn right away is to say, well, that the special product a plus b times a minus b ends up being a squared minus b squared. So you could just memorize this, or you could learn where it comes from so that eventually when you forget it, you can be like, wait, where did that come from? So I'll give you an example. Let's say I had 3 plus 5 times 3 minus 5. The way that I would apply this theorem is to say, okay, so those two numbers are the same, but one has a plus and one has a minus. So the answer would be 3 squared minus 5 squared, which would be 9 minus 25, which is supposed to be 16, negative 16. Now if I try it on my own, I've got 8 times negative 2, which is in fact negative 16. So that's good. So in this one exact example, this works perfectly. That's just the application of it. So if I had x plus 7 times x minus 7, then that means that the solution to that would be x squared minus 7 squared, or x squared minus 49. And again, having these memorized just means that you can save the step of having to do, okay, I've got the first, and I've got outer, and then I've got inner, and then I've got last, and you have to go through all that. Rather than doing that, you can just pop straight into the last thing. Now that said, let me go ahead and do that for you just so you can kind of see how that happens. I'll do that more formally instead of just kind of off the side. So if I've got first, outer, inner, and last, okay, so I've got first is x times x, and then outer, I'll do it this way, inner, and last. Okay, first, outer, inner, last. So outer would be x times negative 7, inner would be 7 times x, and last would be 7 times negative 7. Okay, so what you're going to see happen here is this is going to be x squared minus 7x plus 7x minus 49. Now, that 7x, that cancels out to where you just end up with x squared minus 49 every single time. Well, not every, for x plus 7, x minus 7. But what I mean is every single time that you have that plus something minus something, that those inner and outer terms end up canceling out so that you end up with this nice pretty solution. So again, this is something that you want to kind of put to memory, not because you don't know where it came from, but because it just makes factoring so much easier. So that's definitely one that you're going to want to have memorized. The next special product that you would want to know, and again, this is just going to help you later on when we do factoring. The next special one that you're going to want to know is a plus b quantity squared. Now the official thing to know is that that's going to be equal to a squared plus 2ab plus b squared. Okay, so that's the thing to memorize. Now again, if we're just kind of practicing and seeing how this would be applied, so if I had a 3 plus 5 quantity squared, then it would be the first term. Here, let's do it that way. Actually, let me write it in colors. So let's pretend I had 3 plus 5. And this is all squared. Okay, so 3 plus 5 squared. So the first thing would be the a term, which is 3 squared, plus 2 times the a term times the b term, and then plus the b term squared. Okay, so anything in black is just part of the standard formula. Anything in color is the variable as it's moving through the system. So I have 3 squared is 9, plus 2 times 3 is 6 times 5 is 30, plus 25. I I can't do that in my head. Yeah, I can. 39, 25, there we go, is 64. Now you could probably have figured this out by saying 3 plus 5 is 8 and 8 squared is 64, so you're good to go, but we did get the same answer both ways. So again, you should be marginally convinced that this formula sort of works. But again, it's one of those things that you're going to commit to memory so that if you see something that says like x plus 3 squared, I can apply the formula. So I know that it's going to be first term squared plus 2 first term, second term, plus last term squared. Okay? So again, if this is my x, my first term, it's going to be x, then it's going to be 3. So that's x squared plus 6x plus 9. Okay? Again, it's just supposed to help you write that out a little bit faster and help you recognize things whenever we're going to be factoring. But again, it's really something that comes with experience, and that's really frustrating. So a lot of times people are like, you know, whenever you're doing math, you shouldn't just do lots and lots and lots of problems because that's not going to help. That's like saying, if you want to play basketball, you should not try to shoot lots and lots of baskets and do lots and lots of drills because that's not going to help. Clearly it does. So if you're getting stuck on this stuff, the more practice that you can get with it is going to help. The more you can go out there and just do these same problems over and over. Using this kind of box method is another thing that I've seen be kind of helpful. But again, just kind of recognizing it. Okay. And another one you see that's really similar is a minus b quantity squared. That's going to be that's going to be a squared minus 2ab plus b squared. So it's really the exact same thing as the other one. Can you see them both? Yeah. So it's basically the exact same thing as the other one, except here there's a plus plus, and here there's a minus minus. But notice that both of them have a plus here. These are both plus signs. Okay. The only thing that changes is that middle term. Okay. And again, this is a result of just foiling it out. If I have a minus b times a minus b, and I wanted to FOIL it out, a first, outer, inner, last, you're going to get first is a times a, outer, a times negative b, inner, negative b times a, and last, negative b times negative b. So you have a squared minus ab plus b squared. So basically the reason that this thing right here is always a plus is because you're getting that negative b times a negative b, and that ends up being a positive b squared. But you'll also see a squared minus ab, that's just going to be a squared minus 2ab plus b squared. Okay, so again, it's just one of those things that if you learn it, it maybe helps you go a little bit faster. So if I had x plus, let's make it 3x plus 7 quantity squared, I could either do the FOIL method, or I can say, okay, I know it's going to be in the term, or in the setup. First term squared minus 2 term plus term squared. So you've got 3x. Now that 3x, that whole thing's going to be squared, so make sure you've got that. And then 7. So we have 3x quantity squared minus 6x times 7 plus 49. Now 3x quantity squared, hopefully you remember that's 3 squared times x squared. And that's going to be 9x squared minus 42x plus 49. So along that route. Good. Good. Now the last two I'm going to show you are cubing a binomial. So we can either say a plus b cubed. That's going to turn out to be a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus b cubed is going to be a cubed minus 3a squared b plus 3ab squared minus b cubed. All right. Now, my deal has always been, I find doing this just about as annoying, or memorizing the formula here is actually, for me, worse than actually working the problem out. So you can either memorize this and apply it just like we did before. So let me just give you an example with the first one. Let's say I had, x plus 7 cubed. So I could go in, if I had x plus 7 cubed, and I could say, well, I have the first thing cubed plus 3 first thing squared second thing plus 3 first thing second thing squared plus second thing cubed. And then I could go plug in my x, and my 7, 7, 7. So you can kind of do it that way. So I've got x cubed plus 21x squared plus 3x times 49. Oh gosh, I don't know what that is. Plus whatever 7 cubed is. 63, 28, 34. Yeah, that makes sense. So then 49 times 3 is 147. All right, so I'm not picking bad numbers off the top of my head. 21x squared plus 147x plus 343. So you could do it that way by memorizing the formula. But I'm going to be perfectly honest that I tend to get super lazy. And so I end up just working it out like this to say x plus 7 times x plus 7 times x plus 7. Now, we do know x plus 7 squared. So if you wanted, you could also do x plus 7 squared first and kind of go, let's go do this by itself. Okay, so if we take this one and we go by itself, we know that it's going to be in the term first thing squared plus 2 first thing last thing plus last thing squared. So we could say, okay, well, that's going to be that with the x's there and the 7's are there. So we've got x squared plus 14x plus 49. So that's all that first part. See, I don't know what's easier. Memorizing, the thing is I always memorize that other formula wrong, so I always end up having to do it this way anyway. So that's why I'm showing you both ways. It's just so that you have that as an option. All right, so I've got x squared plus 14x plus 49, and that gets multiplied by x plus 7. Now I'm going to do that distribution thing where I say, okay, this guy, oh, not yellow again. Let's not do that. We say this guy wants to get multiplied by everything, this guy wants to get multiplied by everything, and this guy wants to get multiplied by everything. So the x squared wants to get multiplied by x plus 7. So the x squared wants to get multiplied by the x plus 7. The 14x, the 14x wants to get multiplied by the x plus 7. And the 49 wants to get multiplied by the x plus 7. Then I do the distribution. Do-do-do-do, do-do-do-do, and do-do-do-do. All right. Again, I'm not really sure which is worse. So x squared times x plus x squared times 7 plus 14x times x plus 14x times 7 plus 49 times x plus 49 times 7. X cubed minus, so I guess memorizing the formula is easier as long as you can memorize the formula correctly. What's 14 times 7? Did I already do that somewhere? 88. And 49 times 7 was 343. And now I'm just combining like terms. So this one and this one go together, and this one and this one go together. Please let me get the same answer both ways. What's 7 and 14? Come on, I can do this. 21. And then 98 and 49. And then 343, which, if someone's looking out for me, those will be the same answers I got before. And they are. Who'd have thunk it? I'm amazing. Okay, so whenever I did it the way I was supposed to do it, I got x cubed plus 21x plus 147 plus 343, and I got the same thing the other way. So again, let's scroll out even more. Clearly, doing it the way you're supposed to do it is better and faster and easier to see, but also clearly if you don't memorize the formula correctly or have it written down somewhere, it doesn't do you any good. So again, I just wanted you to see there's more than one way to do this, but as you can see, it's probably in your best interest to go ahead and memorize that formula so that you don't have to go through all of that big giant mess.